Hi, this video is for people that are studying and preparing for the Level 3 Algebra at Excel qualification. In this video, I'm going to go over this essential skills pack that I've put together that is to give you the foundation skills that you need to be successful in your Level 3 Algebra exam. So, there's a selection of topics that I've picked out that you will be able to see on the screen that are designed to give you the best possible chance of being successful. I don't cover every single topic in this video, so there will be some parts of the course that won't be covered. However, most of the course is covered, and I think that if you're able to master all of these essential skills, then I would feel very confident for you that you would be able to pass the Level 3 Algebra exam paper. This particular resource will be linked down in the comment section below. However, I will also make this available via my website, which is www.mathup.co.uk. There are 5 worksheets in the pack, and I will be going over worksheet 1 during this session. Ideally, you print off the first set of worksheets and you have a go at those questions beforehand, and then you watch the video to help you understand any parts of it that you don't understand, and maybe use a different coloured pen and just do any corrections as you go along. Alternatively, you might want to just work through with me, pause the video itself at certain points and have a go at the questions first that way. And as I said, I will work through all 25 questions of worksheet 1 now. Okay, so question 1, we need to factorise the expression x squared plus 5x take away 14. So for me to factorise this expression, I know there's a coefficient of just one of my x squared, so I can simply just look for two numbers that multiply together to give me negative 14 and add together to give me 5. Okay, so the two numbers I've identified are 7 and negative 2, so I would write this as x plus 7 times x take away 2. Question 2 says make x the subject of the formula y is equal to x over 7 take away 3x. Okay, so I'm going to take a little bit longer to do this question here, so I'm going to start by multiplying both sides by 7 take away 3x. So I'm going to write over here, that's going to give me y times 7 take away 3x on the left hand side, and my right hand side is going to say x. And then I would want to expand the brackets out because I'm trying to isolate my x over here, so that's going to give me 7y and take away 3xy is equal to x. Okay, I'm running short on space here, so I'll draw a little line here so I can move over to here. So I've now want to isolate my x, so I'm going to gather all my x terms onto one side, so that means I'm going to add 3xy to both sides of this equation. So that's going to give me 7y is equal to x plus 3xy. I'm now going to factorise because I only want my x to be mentioned once at the moment, it's mentioned twice. So if I factorise it, I've got 7y is equal to x. And inside my brackets here, I'm going to have 1 plus 3y. Okay, and then finally, to isolate my x, I now need to divide both sides by 1 plus 3y. So I'll do it over here. So I'm going to have 7y over 1 plus 3y is equal to x. And I would prefer to write that as x is equal to 7y over 1 plus 3y. But either of those would be correct. Okay, on question 3, I'm simplifying for part A 5 root 3 squared. So that essentially is going to be 5 root 3 times 5 root 3. So this is question A, 5 root 3, and I want to multiply that by 5 root 3. So I can do the 5 times 5 bit because that's going to give me 25. And the root 3 times root 3 bit is just going to give me 3. So I've got 25 times 3, and I know that that is going to give me 75. Okay, so part A, my answer is going to be 75. Part B, I want to do simplify root 72 take away root 50. So I'm looking for the highest square factor of 72 so that I can simplify that part of it first of all. Now I know the number 36 goes into 72 and that's a square number, and 36 times 2, sorry, I can write this as root 36 times root 2, and root 36 is 6, so that's going to simplify to 6 root 2. And then I'm going to take away, and root 50, 25 goes into 50, which is a square number, that's the highest one, so that would be root 25 times root 2 to give me root 50, and root 25 is 5, so that's going to be 5 root 2. And I can simplify that now because 6 root 2 take away 5 root 2 is just going to give me 1 root 2, or just root 2. Okay, so root 72 take away root 50 simplifies to just root 2. So question 4, we're still sticking with surds here. I've got to expand the brackets, 3 plus root 5 multiplied by 3 take away root 5. Okay, let's do each in turn. So I've got 3 times 3 first of all, and that's going to give me 9. I've then got 3 times root 5, but it's going to be take away, so that's going to be take away 3 root 5. And then I'm going to do root 5 times 3, and that's going to be 3 root 5, so I'm adding 3 root 5 now. And then I've got a positive root 5 times by a negative root 5, and that's going to give me a negative 5. Okay, so that's going to be take away 5. Okay, so these are now my full terms, so I need to gather together my like terms, so I can see this negative 3 root 5 and this plus 3 root 5, so those two are going to cancel each other out. And then I've got this 9 take away 5, and that's going to give me 4. Okay, so this here simplifies to 4. Okay, on question 5, we're still sticking with surds over here. This time we want to rationalise the denominator. And we've got 1 over 3 take away root 2. So what I want to do here is I want to multiply this. To change this into a rational, I need to multiply by the conjugate of 3 take away root 2. So that's going to be 3 plus root 2. And I also need to do that on the numerator. Okay, so if I now multiply this out, the numerator, I'll do it over here, is going to be 1 times 3 plus root 2, which is just going to be 3 plus root 2. And the denominator, I'm essentially going to do this multiplied by this. So I'm just going to write that out first. 3 plus root 2. Okay, so that's what I'm aiming to do. So if I carry this on, I've got 3 plus root 2 that stays on my numerator, and on my denominator I'm now going to expand this out just like I did before, so 3 times 3 gives me 9, and this time I'm just going to be quicker because I know that 3 times root 2 gives me 3 root 2, and there's a negative root 2 times 3, that's going to give me a take away 3 root 2, so those two terms are going to cancel each other out. Okay. And that's because this is a conjugate of that. I chose that to happen because I was trying to rationalise the denominator. Okay, so I've now only need to do the negative root 2 times the positive root 2, and that's just going to give me a negative 2, so that's going to be take away 2. So my answer for this over here is going to be 3 plus root 2 over 7. Okay, question number 6. We are simplifying p cubed times p to the power of 5, and then we want to take that to the power of negative 2. So for this question here, I'm going to start by doing the parts inside the brackets, and for this I've got the same base, so I just need to add the powers. So that's going to give me p to the power of 8, but I also still need to do to the power of negative 2. And now using my laws of indices, I know that I now need to multiply these powers together. Okay, so that's going to be p to the power of 8 times negative 2, which is negative 16. Okay, question 7. We need to simplify this expression over here. So I've got 3t to the power of 4, and then we're cubing it. So that essentially means 3t to the power of 4 times 3t to the power of 4 times 3t to the power of 4. Okay, so to do this, I know that my 3 is going to be raised to the power of 3 because I need to multiply that 3 times. and t to the power of 4 is also going to be raised to the power of 3. So the 3 to the power of 3 bit, that's going to give me 3 times 3 times 3, which is 27, and t to the power of 4 to the power of 3, that's where I have to multiply the index numbers together, and that's going to give me t to the power of 12. Okay, so I get 27 t to the power of 12. Okay, question 8 says, use the quadratic formula to solve the equation 3x squared plus 5x take away 7 is equal to 0. So my first job here is I need to recall what the quadratic formula is. So that is going to be x is equal to negative b plus or minus the square root of b squared take away 4ac all over 2a. And I'm now going to write down the values of a, b, c and the discriminant. So a is going to be 3, b is going to be 5, and c is going to be negative 7. And I also always write down the discriminant, and the discriminant b squared take away 4ac is going to be, so it's going to be 5 squared, which is 25, take away 4 times a, which is 3, times c, which is negative 7. So that's going to give me 25. I've got negative 4 times 3 times negative 7, so the negatives are both going to multiply together to give me a plus. 4 times 3 is 12, and 12 times 7 is 84. And 25 add 84 gives me 109. Okay, so the value of my discriminant is going to be 109. I'm now going to use the formula. So that tells me that x is going to be equal to negative b, which is going to be negative 5, plus or minus the square root of b squared take away 4ac, which I've worked out here. The discriminant is 109, so it's going to be the square root of 109, and divided by 2a. So that's going to be divided by 2 times 3, which is 6. Okay, so in your exam, quite often you can leave your answer like this. Sometimes it will tell you which form to write your answer in, so you just need to watch out for that. Okay, but quite often just writing your answer like that is absolutely fine. Okay, question 9. We're being told that we want to find the range of possible values of a such that ax squared plus 3x take away 7 is equal to 0 has no real roots. Okay, so as soon as I see no real roots, that's going to happen when my discriminant is negative, yeah, because we can't square root a negative number and get something real. So I know that my discriminant would need to be negative. So I'm going to start by writing down that b squared take away 4ac must be less than 0, because remember, less than 0 is negative. Okay, so I'm going to again start by writing down what my values of a, b and c are. So here a is just going to be equal to a, we don't have a value for it. B is equal to 3 and c is equal to negative 7. So I want my discriminant to be less than 0, so I'm going to write down what each of these values are. So b squared is going to be 3 squared, which is 9, take away 4 times a, which is just called a over here, times c, which is negative 7. Okay, and I want that to be less than 0. Okay, so I've just substituted these values in over here into this inequality. Okay, I'm now going to expand this part out. So I've still got this 9 over here, and I'm going to take away 4a times negative 7. So I know 4 times negative 7 is negative 28. So I'm taking away negative 28, which is going to be plus 28. And we've still got this a over here. And I need that to be less than 0. So I can now solve this inequality. I can subtract 9 from both sides. So that's going to give me 28a is less than, and 0 take away 9 is negative 9. And then finally, a is going to be less than, and I need to divide both sides by 28, so it's going to be negative 9 over 28. Okay, and that doesn't simplify, so that in fact would just be my answer. Remember, in level 3 algebra, we don't have a calculator, and so we wouldn't try to work anything out as a decimal. We would normally just leave our answers as fractions, and it's not always pretty fractions. Okay, question 10, we need to find the sum and the product of the roots of this equation over here. 2x squared take away 6x plus 3 is equal to 0. Okay, so I'm going to first of all just remind myself to work out the sum of the roots. I know that that's going to be negative b over a, and to work out the product of the roots, that's going to be c over a. Okay, so we need to have that stored in our memory. Okay, so I'm going to write down the values of a, b and c again, so I can see that a is equal to 2, b is equal to negative 6, and c is equal to 3. Okay, and it's always helpful to write these things down, okay, so it minimises any opportunity for you to make any mistakes. So my sum, negative b over a, well that's going to be, b is negative 6, I want the negative of negative 6, which is a positive 6, over, and a is 2, so it's going to be 6 over 2, which is 3. For the product of the roots, that's going to be c over a, and I can see that c is equal to 3, a is equal to 2, and that gives me 3 over 2, and in fact I just leave that as 3 over 2. Okay, in question 11 we are sticking with sums and products, but this time we need to find the quadratic equation with integer coefficients, so we want whole number coefficient where the sum of the roots is negative 2/3 and the product of the roots is 1/3. So I'm going to write down that I know that the sum of the roots, that's negative b over a, and I know that's going to be equal to negative 2/3, and the product of the roots, or c over a, I know is going to be equal to 1/3. So this time I'm going to write down what a, b and c are going to be equal to. Oops, I didn't mean to write that. A, b and c are going to be equal to, and then I'm going to write down what the quadratic equation is that I want. So from here I can see that it would make sense for me to choose 3 because a is 3 in both of these. Okay, so I'm going to choose a to be 3. Negative b over a is negative 2 by 3, so the value of b must be 2. Okay, because if a is 3 and b is 2, negative b over a would be negative 2/3, so we can see that. And then for c, I can see that the value of a is 3, so the value of c is going to be 1. So I had written that accidentally already earlier, but that's where it is. C is equal to 1. Okay, in question 12 we have a question that is on direct proportion. So P is directly proportional to Q. So as soon as I see this, P is directly proportional to Q, I'm going to write down that P is equal to something, which I'm going to call K times Q. We're being told that when P is equal to 20, Q is equal to 5. And we want to write down a formula for P in terms of Q. So I'm going to use this information to work out what K is so that I can write down my final formula, which won't have a K in it. So P is 20, Q is 5, so I'm going to substitute 20 here, and I'm going to substitute a 5 for the Q, so that's going to be K times 5, which is 5K. And that tells me that K is going to be, if I divide both sides of this by 5, that tells me that K is going to be 20 divided by 5, which is just 4. Okay, so I now know the value of K is 4. I can write down the formula for P in terms of Q, because P is going to be equal to, and instead of KQ, I'm going to say 4Q. So to be clear, the answer to that question is P is equal to 4Q. Okay, in question 13, what is the nth term of the following sequence? And we've got the sequence 6, 10, 14, 18, 22. I can see that this sequence is going up by 4 each time, so I'm going to start by writing 4n. And I can see the first number in the sequence 4n would be 4 times 1, which is 4, but this one here is 2 more than that. So I'm going to write my sequence as 4n plus 2. Okay, now I'm always going to check this, so I'm just going to choose the fifth term to check it in. So if I was using the fifth term, 4 times 5 is 20, and 20 and 2 gives me 22, and I can see that matches with the fifth term in the sequence. Okay, question 14. We need to find the sum of the first 20 terms of the arithmetic series 2 plus 5 plus 8, etc. Okay, so I'm trying to find the sum of a series here, so I need to use one of my formulae. I'm going to start by writing down what information I know. So I know the first term, a, is equal to 2. I also know the common difference, because that's how much it's going up by each time. Because it's arithmetic, it's going to have a common difference. So that is going to be plus, it's a positive 3, it's going up by 3. So I'm going to write down that d, the common difference, is equal to 3. And then I also know the number of terms that there are. Okay, there's 20 terms, so I'm also going to write down that I know that n is equal to 20. Okay, I don't know what the last term is at the moment. I could work that out, but what I'm going to do is I'm going to use my formula, or the version of my formula, where the sum of the n terms is equal to a half of n times 2a plus n minus 1d. Okay, so that is the formula that I'm going to use. So I know what n is, I know what a is, I know what d is, so I should just be able to substitute all my values into this formula. So the sum of n terms I've got here, but I know that there's 20 terms, so I'm going to say the sum of the first 20 terms is equal to a half of n. N is 20, so it's going to be half of 20, which is 10. And I'm going to multiply that by 2a, which is 2 times 2, which is 4, plus n minus 1 times d. So n minus 1 is 20 take away 1, which is 19, times the common difference, which is 3. Okay, so I'm going to evaluate inside the brackets first. Let me just come over here. So inside the brackets, I've got 4 plus 19 times 3. So I've got 4 plus, we'll do it in one step at a time. So 19 times 3 is 57. So that means the sum of my first 20 terms, I've got the 4 plus the 57, which is 61. So I've essentially got 10 times 61, which is 610. Okay, so my answer for this one is going to be 610. Okay, question 15 says, find the equation of the line passing through the 2 points 2, 3 and 5, 12. Okay, so this is quite a common situation that we will encounter where we're trying to find an equation of a line where we know 2 of the points. So my first job here, to get the equation of the line in the form y equals mx plus c, is to work out what m is, or the gradient is. Okay, so I'm going to write down these points, and I'm just going to write them one on top of the other, just so I can be really clear with myself what's going on. Okay, so to work out the gradient, I need to do, and I know it's going to be the change in y divided by the change in x. Okay, so where I've got these two coordinates here, I'm going to work out how much the y coordinate has changed and how much the x coordinate has changed. So the y coordinate has increased from 3 to 12, so it's increased by 9. My x coordinate has also increased from 2 to 5, and that is an increase of 3. Okay, so my change in y is going to be 9, my change in x is going to be 3. So change in y is 9, change in x is 3. So my gradient is going to be 9 divided by 3, which is just 3. Okay, so sometimes you get it as a fraction, but we've got it as an integer this time. Okay, so I now want to find the equation of the line. Okay, so over here now, I'm going to say, well, I know it's going to be in the form y equals mx plus c. but I also know that m I've worked out to be as 3. So I'm going to say I've got y is equal to 3x plus c. So what I now want to do is I want to work out, well, what is the value of that c? So I'm going to choose one of these points to substitute into here so that I can work out what that c is. So I'm going to choose this point here. So here the x coordinate is 2 and the y coordinate is 3. So I'm just going to write, well, when I know that when x is equal to 2, y is equal to 3, because that's one of the points. So I'm now going to substitute these values into here so I can work out what c is. So y, or 3, is going to be equal to 3x, and I now know that x is 2, so 3 times 2, which is 6, plus c. That tells me that c must be 3 take away 6, which is negative 3. So I now know that c is equal to negative 3. Okay, so I now know what m is. It is 3, and I know what c is. It's negative 3, so my equation is just going to be y is equal to 3x take away 3. The m and the c. Okay, so that's the equation of the line that would pass through both of these points. Just as a final check, what I would often do is just see whether it works. So in this coordinate here, the other one, I'm just going to check that 3 times the x coordinate take away 3 does in fact give me the y coordinate. So 3 times 5 is 15, take away 3 does in fact give me 12. So I know that I've got it right. Question 16, we're factorising the expression 2x squared plus x take away 3. Because I've got a coefficient of my x squared here, I'm going to have to use the AC method to work this out. So I can do it a different way, but I'm going to use the AC method. So I'm going to write down what AC is, the value of AC. So that's going to be 2 times negative 3, which is negative 6. And I'm going to write down what the value of b is, and we can see that the value of b is just going to be 1. Okay, so I want two numbers that multiply together to give me negative 6. I should have written negative 6 there, so negative 6, and have a value, they add together to give me 1. Okay, so the two numbers that I know that multiply together to give me negative 6 and add together to give me 1 are going to be a positive 3 and a negative 2. Okay, so I've got a 3 and a negative 2, that gives me the 1, and then multiply together to give me the negative 6. So I'm now going to split the middle on this expression here. So instead of 2x squared plus x, I'm going to write 2x squared plus 3x take away 2x. Take away 3. Okay, so I'm now going to factorise this part over here. So I factorise this. X is a common factor, so that's going to be x. And then inside here I'm going to have 2x plus 3. And then I'm going to factorise this part over here. And it's a takeaway, so I'm going to put negative 1 outside. And then inside I'm going to have negative 1 times 2x gives me the negative 2x, and negative 1 times, and it needs to be a positive 3 to give me the takeaway 3. Okay, so now I've got a 2x plus 3 here and a 2x plus 3 here. So writing this in factorised form, it's going to be x take away 1 times 2x plus 3. Okay, so my answer is going to be that there. A little bit squished there, but hopefully we followed that part of this. In question 17, we need to write the this expression here in this form here. So essentially we're being asked to write this in completed square form. Okay, this part here is just telling us to write it in completed square form. So I've got x squared plus 8x take away 10. Okay, so first thing I would do is I'm just going to concentrate on this x squared plus 8x bit, and that is going to be, so I'm going to write it as x plus 4 squared, because I know that part's going to give me the x squared plus the 8x bit, but I'm going to have a plus 16 on the end that I don't want, so I'm going to take away 16. That's that part there, and then I'm going to subtract the 10. Okay, so altogether I'm going to have x plus 4 all squared, take away 26. And that is now in completed square form, but it's in the form that we're being asked for. Okay. Sometimes you might be asked to give the value of p and q. In this case, I would say because that's plus p and I've got plus 4, so p must be 4. And because that's plus q and I've got to take away 26, then the q must have a value of negative 26. Question 18, we're factorising ab take away 4a plus 5b take away 20. So my first job when I'm factorising anything is I'm looking to see whether there's a common factor. And I can't spot a common factor between each of these terms, so that's not going to work. But what I can spot is that there's a common factor of ab and take away 4a. And separately there's a common factor of 5b take away 20. So what I'm going to do is I'm going to factorise these parts separately. The ab take away the 4a has got a common factor of an a. So I'm going to take a outside my brackets here, and inside my brackets I'm going to have, so that needs to be b to give me the ab, and that needs to be take away 4 to give me the take away 4a. Okay, so I've got a times b take away 4. And now over here I've got a common factor of 5, yeah, a common factor of 5 for 5b and 20. So I'm going to put plus 5 outside my brackets, and inside my brackets I'm going to have b take away 4 for that part. And as you can see, I've got b take away 4 as a common term in both of these, so that means that I can write this now as a plus 5 times the common factor of b take away 4. So that there is this factorised. Now in question 19, we need to find the equation that is perpendicular to the line y is equal to 3x plus 5 and passes through the point negative 6, 4. Okay, step 1 here is I need to find the gradient. Okay, so I know that the gradient of our line that we're trying to find is going to be perpendicular to this one here. The gradient of this one is 3. So for our line, because it's perpendicular, it's going to be the negative reciprocal of that 3. So the gradient of the line that we want is going to be negative 1/3. Okay, and that's the negative reciprocal of the gradient of this line. Okay, now I know that part of it, so I know that I can now write down my equation is going to be y is equal to negative 1/3 x plus c. However, I want it to pass through the point at negative 6, 4. Okay, so I'm now going to use that information to work out what the value of c is. Okay, so I've got y is equal to negative 1/3 x plus c, but I know that when x is equal to negative 6, y is going to be equal to 4 in order for it to pass through that point. Okay, so I'm now going to substitute these values into this equation here so I can work out what c is. So instead of y, I'm going to say 4, and it's going to be a negative 1/3 times x, and instead of x, I'm going to say negative 6 plus c. So that's going to be 4 is equal to, and I want to do a negative 1/3 times a negative 6. Okay, and because they're both negative, it's the same as doing 1/3 of 6, and 1/3 of 6 I know is 2. So it's going to be 4 is equal to 2 plus c. And I should be able to see from here, I can subtract 2 from both sides, but I should be able to see that c must be equal to 2. Okay, so now that I know that c is equal to 2, I can write down the equation. Instead of the c, I'm going to put a 2, so I've got y is equal to a negative 1/3 of x plus 2. and that there is going to be the line that's perpendicular to this one and passes through the point -6, 4. Okay, in question 20, we need to write this expression here in completed square form. Okay, so this one's a little bit different because we've got a coefficient of our x squared, okay? So it's not as straightforward when we're completing the square where that's the case. So what I'm going to do is I'm going to section this part of it off, and I'm just going to factorize that part of it. Okay, so I can see there's a common factor of a 3 in this part of it. So I'm going to write 3, and I'm just going to open up some square brackets here, and I'm going to write this as x squared plus 4x, and then close those brackets off. Okay, so this part here now is the same as 3x squared plus 12x, okay? But I've still got this take away 5, so I'm going to put that take away 5 on the end. Okay, so this expression and this expression is the same. The reason why I've done that now is I can now complete the square on this part of the expression. So x squared plus 4x, that's going to be the same as x take away 2 squared, so I'm completing the square on it. And then that's going to give me an extra 4, so I'm going to take away that 4. Okay, and then I've still got this take away 5. So the part inside the square brackets here, I've completed the square on, and I've got this here. I'm now going to lose the square brackets by expanding it. So I've got 3 times x take away 2 all squared, and then I'm going to take away, and I've got 3 times 4, which is 12, and then I've also got this take away 5 over here. I can just tidy this up because that last part will simplify. So I've got 3x take away 2 squared, take away 12, take away 5, which is the same as just taking away 17. Okay, and that's going to be that in completed square form. Okay, question 21. A graph has equation y is equal to f of x. Point A, we're being told, has coordinates 6, 4, and is on the graph y is equal to f of x. We need to transform point A to each of these other graphs. Okay, so part A, so my new graph, it's going to be my same function, but this time I'm going to multiply it by -2. Okay, so y is equal to -2 times f of x. So that's telling me that I just need to multiply the y coordinate by -2. So the x coordinate is going to stay where it is, the y coordinate is going to be multiplied by -2. So that's going to be 6, and 4 times -2 is -8. Okay, in part B, this time I've got y is equal to f of x take away 2 plus 3. So this time my input is being changed. So remember, when my input changes, I'm going to do the opposite of that to the x coordinate. Okay, because it's inside my actual function input, and that's why that happens. So that's 6. Because the input, because I'm saying take away 2 there, I'm actually going to add 2 to that 6. So that's going to become an 8. And then this is happening to the actual, the whole function. We're adding 3 to it. So I'm just going to add 3 to that 4 there, and that becomes 7. Okay, so for part B, we're going to have 8, 7. For part C, this time again, we've got our input that's changing. Our input is being multiplied by 2, so I'm going to have to do the opposite of that to my x coordinate, and that tells me that I'm going to halve my x coordinate. The opposite of multiplying by 2 is dividing by 2, so I'm just going to halve it. So that's going to become 3, 4. Okay. Question 22. We want to solve an inequality this time, and the inequality is x squared plus 8x plus 15 is greater than 0. Okay, so my first job here is I want to factorize this expression over here. So I can see, to factorize this, I want two numbers that multiply together to give me 15 and add together to give me 8. So I make those 3 and 5. So I'm going to rewrite this as x plus 3 times x plus 5 is greater than 0. Okay, I'm now going to write down what my critical values for this are. Okay, so my critical values are essentially what would happen if this was an equation that was equal to 0. Well, that will tell me that x would be equal to -3 and x would be equal to -5. Okay, it's not equal to 0, but we're just seeing what would happen if it was equal to 0, and that tells me my critical value. Okay, and those are important because they're going to tell me when I sketch the graph where they're going to cross the x-axis. So I'm now going to sketch the graph over here. Okay, so that's my x-axis, that's my y-axis, and I can see that it passes through -3 and -5. So -3 is going to be here somewhere, -5 is going to be here somewhere, and so I'll mark those in, -3, -5, and I know that if I was drawing the graph y is equal to x squared plus 8x plus 15, it would be a parabola, and it would be a positive parabola, so it would be a happy face parabola. Okay, so it's going to look like that there. Now, I want for this to be greater than 0. Okay, so I'm looking for when this curve is above my x-axis, because I want the y-coordinates of it to be positive or above 0. Okay, so this is going to be above the x-axis when the x-coordinates are anything on this side of my -3. Okay, so I'm going to essentially want all of these numbers in this direction here, but it's also going to be above the x-axis for anything on this side, for any x-coordinate on this side of my -5. Okay, any of those x-coordinates are going to give me a positive y-coordinate, so I want all of the numbers on this side as well. Okay, so I can see that I've got two separate regions here. Okay, so I'm going to have to describe these regions separately. So this region here, well, these are all the values where x is less than -5. So I'm going to write x is less than -5. And this region here are going to be all the values when our x-coordinate is greater than -3. So I'm going to say or x is greater than -3. So if my x is less than -5, or if it's greater than -3, I'm going to get a positive y-coordinate for those x-coordinates, and therefore it's going to be greater than 0. Okay, just to highlight here, this was a strict inequality, so it couldn't actually be equal to 0, and that's why these were open circles here, and that's why we have strict inequalities here as well. Question 23, we've got an algebraic fraction here that we want to simplify. So I'm going to look at the numerator and the denominator in turn, and I'm going to see if I can spot any common factors. So I've got x squared plus 7x plus 12, there's no common factors in these terms here. X squared plus 5x plus 6, there's no common factors in this term here. Okay, so what I'm going to have to do is I'm going to have to start by just factorising it, and I can spot that's a quadratic, and I know that that can factorise. Okay, so I'm going to write down over here that numerator in factorised form. So two numbers that multiply together to give me 12 but add together to give me 7 are going to be 3 and 4. So I'm going to rewrite the numerator as x plus 3 times x plus 4. Okay, because I know if I expand that I'll get that there. And then the denominator is x squared plus 5x plus 6, but I know that if I factorise that I'm going to get x plus 2 times x plus 3. Okay, so now I've written it in factorised form, I'm going to spot to see if there's any common factors on the numerator and the denominator, and I can see that the highest common factor of the numerator and the denominator is going to be x plus 3. So I can divide the numerator by x plus 3, and I can also divide the denominator by x plus 3. Okay, so if I divide the numerator by x plus 3, that's going to give me x plus 4 on my numerator, and if I divide the denominator by x plus 3, that's going to give me x plus 2 on my denominator. So my answer is going to be x plus 4 by x plus 2, and that doesn't simplify anymore, so that will be my final answer. Okay, question 24, we want to write in the simplest form 2 by x plus 3 plus 3 by x plus 2. Okay, I've decided I've not got enough room here to do this question, so I've just written it out separately over here so I can make it really clear what I'm doing. Okay, so this is the question that we're trying to work out. At the moment, I can't add these fractions together because I don't have a common denominator. So my first job is to decide, well, what should I make my common denominator? So I've decided that I'm going to make my common denominator x plus 3 times x plus 2. Okay, so I'm going to rewrite both of these fractions with a common denominator of x plus 3 times x plus 2. Okay, and I've essentially got that by multiplying these two together. Okay, so I'm going to rewrite this fraction with this so that it works with this denominator here. So to change x plus 3 into x plus 3 times x plus 2, I've had to multiply it by x plus 2, so I need to do the same thing to the numerator. So I'm going to do 2 times x plus 2. Similarly over here, to change that x plus 2 into x plus 3 times x plus 2, I've had to multiply it by x plus 3, so I'm going to do the same thing to the numerator. I'm going to multiply it by x plus 3, so I've got 3 times x plus 3. Okay, so I'm now going to, I should now be able to add these together because I've got a common denominator, so I'm going to do just add the numerators together. So that's going to give me 2 times x plus 2 plus 3 times x plus 3 on my numerator, and my denominator is just going to stay as x plus 3 times x plus 2. Okay, so now remember, you don't need to multiply, expand this out on the denominator, but on the numerator, if we do expand it out, I know that that will simplify, so that's what I'm going to do. So my next line over here now, I'm going to expand this out, so I've got 2x plus 4, and then I've got plus, and that's going to be 3x, and then it's going to be plus 9. Okay, so that there is my numerator, and my denominator is going to stay as this here. Okay, and that simplifies on the numerator, so 2x and 3x is 5x, and that 4 and 9 gives me 13, so I've got 5x plus 13, and on my denominator I've just got x plus 3 times x plus 2. Okay, and whoops, close my brackets there, and that there should be my final answer for that one there. So that takes us to our last question, which is to solve algebraically the simultaneous equations, and I've got x take away 2 all squared plus y squared is equal to 8, and then I've also got y is equal to x take away 6. Okay, and I'm going to do this by substitution because I know that y is equal to x take away 6. So where it says y squared here, I can replace the y with x take away 6. So instead of y squared, it's going to say x take away 6 squared. So I'm going to write that down. So that means I've got x take away 2 squared like I had before, plus, and this time I'm going to have, instead of y squared, I'm going to have x take away 6 squared. And it's equal to 8. Yeah, so all I've done here is I've substituted that y for an x take away 6. I can now expand these brackets. Okay, so I'm going to do that now. So I've got x take away 2 squared. Remember, that means x take away 2 times x take away 2. That's going to give me x squared. And then I'm going to have take away 2x twice. So that's going to give me take away 4x. and then I'm going to have negative 2 times negative 2, which gives me plus 4. Okay, if you find it easier, then rewrite it as x take away 2 times x take away 2, and then expand the brackets, however you feel comfortable. I'm now going to have a plus, and I've got x take away 6 all squared, so that's going to be x squared, and then I'll have take away 6x twice, so that gives me take away 12x, and then I'll have the negative 6 times the negative 6, that gives me a plus 36. And that is going to be equal to 8. Okay, so I've now expanded the brackets, and I now need to just simplify it, don't I? So I've got, I look for like terms, so I've got an x squared term and an x squared term, so that's going to give me 2x squared. I've got this take away 4x, and I've got this take away 12x, they're going to go together, so that gives me take away 16x. I've got this plus 4 and this plus 36, that's going to give me plus 40 altogether. So that's simplified here on the left hand side, and that's going to be equal to 8. Okay, so I can see now it's shaping up because I'm getting a quadratic equation. I'm going to make that quadratic equation equal to 0. So I'm going to subtract 8 from both sides, so that gives me 2x squared, take away 16x, and instead of plus 40 we're subtracting 8, so that's going to give me plus 32 is equal to 0. Okay, so now the other thing is, I can see now that I've got a coefficient of my x squared, but actually each of these terms divides by 2. So I can simplify this further by dividing each of these 4 terms by 2. So if I do that, 2x squared becomes 1x squared. And if I divide this term by 2, I get 8x. And if I divide by this term by 2, I get 16. And that's equal to, and 0 divided by 2 is 0. Okay, remember you always have to divide everything on both sides by 2. Okay, so I do have to divide the 0 by 2, but it is just 0. Okay, now does that factorize is what I'm asking myself. And I can see that two numbers that multiply together give me 16, but add together to give me 8. Negative 8 is negative 4 and negative 4. So that means I'm going to have x take away 4 times x take away 4 is equal to 0. Okay, and we could have just written that as x take away 4 squared is equal to 0. Okay, that doesn't really matter. I'm trying to solve this now. There's only going to be one solution or a repeated solution, however we think about it. And that solution is going to be x is equal to 4. Okay, so sometimes you'll get 2 solutions. In this particular case, I've only got 1 solution. X is equal to 4. I've not finished yet though, because I now know that x is equal to 4. I need to work out what y is. Okay, I'm told here, and I can substitute it into either of these, but obviously I'll substitute it into this easy one. I'm told here that my y coordinate is going to be my x coordinate take away 6, or x take away 6. So if x is 4, then y is going to be 4 take away 6, which is negative 2. So my y is going to be negative 2. And that there is going to be the solution of those simultaneous equations. Okay, I hope you found that video useful overall. What I would suggest that you do is have a go at the Essential Skills 2 and the rest of the Essential Skills pack, and make sure that you get lots of practice with these. Create some flashcards to help you where there are some questions that you feel that you have struggled on a little bit, or there's parts of this that you haven't remembered. That will be really, really helpful. So good luck with your level 3 algebra exam. I'll see you soon. Take care.